Hello, everyone. I am Nicola Tavaria. I'm the Digital Marketing Manager here at LND Technical Services, and I am so happy today to chat with Deepak Maragal. He is the Global Chief Technology Engineer at LND, and he is known as our technical expert. So we're going a deep dive into some very important topics in the engineering, clean energy, and renewables industry today. So Deepak, thank you so much for talking with me. And if you can give a little bit of a background about yourself and an introduction, we'd love to learn more.
Thank you, Nicole. Hello, everyone. This is Deepak Maragal. I'm the Global Chief Technical Engineer with LND. I have PhD in electrical engineering or 20 years of experience, utility as well as industry consulting experience now, supporting on projects on digital substation, simulation studies, transient studies, BESS projects, solar farms, pretty much anything that's in power system I support, and also in troubleshooting, blackout investigations in the things that requires transient studies and specialized work.
Amazing. Thank you again so much for your expertise. So, one of the hot topics in the renewables, energy, and power systems industry right now is BESS, or battery energy storage systems. Can you go a little bit into explaining what does that actually do for a power grid and why is it so important?
Yeah, this is a good question. The battery energy storage system in general, as we know, this is coming more and more into the grid. People often think that this is related to either solar farms or renewables coming in. There's actually, three unique reasons why BESS is taking more grounds. Number one, first, the BESS, as we know, the load has constantly increased on the grid year over year, right? Because new industry now, also with data centers, very huge, large loads coming onto the grid, whereas generation has not picked up as much, right? So the generation is still the same traditional. The second reason being, again, generation not picking up. And at the same time, you have older coal plants getting retired, and also some of the old nuclear plants also, not getting license renewed. So now there's solar farms and there's lack of generation capacity, and then there are other solar farms and wind farms which lack as much of inertia. Now, to support this, the grid is under more kind of a stability concerns that you are at the higher level of the operating conditions, so you have very little margin. So now you need, when you have a larger loads on the grid, you would need BESS battery energy storage system to support on a temporary basis, right? In case there's a fault, if there's a loss of transmission line or a generation, you don't want to have a cascade blackouts. So you put a battery energy storage system to stabilize the grid and to operate it more efficiently. So that's one main reason. Of course, there is the economics for operating the grid. People say, at least you see quite a few papers, why don't we store renewable energy in the daytime and and use it in the nighttime? With the energy, in many cases, most of the cases, the economics for storing the energy in the battery and running it in the nighttime doesn't exist. In most of the cases, in few locations, yes, of course. So the economics is primarily driven by stability and grid support concerns, as opposed to the energy storage from this point at this time, right? As the battery technology matures, the cost of batteries comes down. For sure, there'll be time when the energy storage for BESS becomes more economical, but that's yet to happen. For large scale energy storage doesn't exist at this time compared to like water, pump water, and so forth. Yeah.
Okay, got it. And I know at L&D we work with clients ranging from really small project sites to larger project sites. So what, in your opinion, are the challenges of integrating like a large scale BESS project into an existing system?
Yeah, this is also evolving thing as we work with constantly from over the years. Battery technologies have changed quite a bit, and they're a lot more powerful than what we saw a couple of years back, just as early as this. And so the newer batteries are definitely far more capable, and they can provide more stability capability to support the grid. So what we see is that, again, there's really need of transformation from utility practices to adapt that better best capabilities onto the grid. So now what we see is some of the challenges is the utility has its own interconnection standard to meet with. So they're not as purview to adapting the new capabilities because they themselves do not know, or it may lead to some other things. So there's really a wider transient or transient studies to be done to address the capabilities. So as we see in some cases, those full capability of the batteries has not been used and you're still following the same old practices. Fine, it's still better, but definitely there's a room for improvement. That's one of the things. When we do that as part of the studies, we share these limitations or capabilities to the end users, and they make the decision whether to increase the margin or how change their practices. And again, it's up to them. So some of them do, some of them don't. Again, this is evolving changes that's happening in the industry as we speak.
Got it. And thank you very much for that. And I know like Lindy does a lot of maintenance projects, protection projects, all these things that a lot of them we turn into case studies. Can you think of an example of how L&D supports BESS projects, like in a protection study or anything like that? Like what exactly does our team do in those situations?
No, absolutely. So this is in L&D, we do pretty much from A to Z of studies settings. Anything that's related to protection, system planning and study configuration and studies. We don't go inside the battery system for configuring the inverters, but we tell here is what the limits has to be. We also gone to say here's what the parameters has to be, tune the parameters for the battery system to make it more optimal configuration to meet the grid requirements. We have studied, there are many different, for BESS, you can think of studies like a transients stability studies for the grid. There's temporary overvoltage studies. There's, of course, when you're doing any substation, there's insulation coordination studies. There is protection coordination studies. All kind of studies are required. Short circuit studies to look at the breaker ratings and prepare protection settings. Equipment verifying the equipment capabilities. And also when, as per the testing and commissioning effort, once this is done, we also do power quality studies. Is very important, especially when it comes to solar farm and BESS energy storage system to ensure, this harmonics is in control. It's not, there's no adverse impact from harmonics. Either onto the grid or the inverter systems themselves.
Thank you again so much. And I know clean energy and especially renewable energy is a large topic of concern, both in the engineering and utility industry, and then also the type of projects that L&D works on. So just an example, I know we've worked on solar farms projects before. So in your perspective, what are some unique engineering challenges that comes with connecting a large-scale solar farm with a power grid? Like, what does that involve exactly?
Yeah, this is another good question. Solar farm have been in use or being studied or integrated for quite some time now. This is not new as BESS. However, even we see the solar farms has several unique challenges, especially when it comes to, as you know, the solar farm that you want to maximize the real power generation. So the reactive power interconnection requirements are met through capacitor banks, and those has to be sized properly to ensure that these, and also there is tap changers in the transformers that has to be optimally configured to ensure, they don't have to derate at any times or higher, power or temperature ratings and so forth. So these are some very small nuances that often discounted, and you see that, down the line when it comes to close to commissioning, we say, hey, this is not okay, this is not done properly. So we go back and redo some of the studies. Sometimes this harmonics, as I was mentioning, you also create challenges with capacitor banks being on the system. I've seen this happening more than 2 or 3 locations in transmission level. So where the capacitor banks fail much more often, and they need to be tuned and so forth. So there's additional studies and tuning needed to ensure the solar farms work optimally. Again, these are some of the major, I would say, new challenges observed in last few years, but still there's work to be done, improve the protection coordination. How can we detect the fault much faster and isolate? How can we do the PRC 26 or the power swing when this happens, not to have the solar farm trip Again, there's other PRC standards related now, especially with PRC 29 and other ones that comes in effect. But besides the point, there's definitely growing need from ensuring the solar farms work reliably and don't trip for grid faults.
Thank you so much, Deepak, for the explanation. And in general, I know L&D pays a lot of close attention to making sure that we're always up to date to the latest industry standards, guidelines, regulations. So just as an example, how would, let's say, the latest IEEE 2800 standards change the way that our L&D team evaluates a solar farm? Can you give a little bit of detail behind that?
Sure. See, the IEEE 2800 is one of the major improvement brought into the standard domain, wherein you're trying to inverter based resource, you're trying to behave it more like a synchronous generator, right? So the conventional synchronous generators have inertia, it has a specific response, and we know it operates well. The inverter based generation, on the other hand, because they're so fast, can operate in very, very kilohertz or tens of kilohertz time frame. If there is a disturbance, they can trip offline right away, or they can support. So those response capabilities, how it has to respond to support the grid is what 2800 tells. The inverter cannot trip offline. It has to support the grid. If there's a fault, it keeps on feeding the fault, and until there are other secondary, the primary protection system isolate, as opposed to it tripping it offline and causing a blackout, right? In case if you lose the generation from the grid, large scale generation, there's a chances where lack of generation can lead to a blackout. So again, this is where the industry, when I say industry, you have seen these kind of events happening in Australia, in Hawaii, in California. I wouldn't say, event as such, but at least there are scenarios where the non-linear response of inverters has led to wide-scale grid scale events of brownouts, blackouts as such. 2800, IEEE 2800 and like standard on the transmission level has come and standardized these things. Hey, the inverter has to behave much, much better, and here is the response needed, and that's what is standardized. And this is the work in progress from the one is standard, but work in progress from the industry, from the inverter manufacturer. How much do we need? Yeah, we can provide this response. How much inertia do you need? What kind of battery systems we have to add? So this is definitely one is telling the standard, but also there's definitely grid requirements. How much does the grid need? So that inverter has to be done. So now on top of this, with 2800 standard, there are other local, regional, and utility specific requirements to ensure, again, the inverter based generation meets the grid requirements in lines with the IEEE 2800. So
Awesome.
this is,
Awesome.
I think, as a whole, this is the whole. I think we'll keep this. That's it.
Yeah, no, that's good. Thank you again. So if people don't know, our L&D HQ is based in Texas. So we've supported a lot of projects in Texas. One of the most recently solar farm projects being an Oriana solar farm project. So Deepak, could you walk us through what kind of studies and protections go into making a solar farm like that specific one ready to connect to the larger power grid? What needs to happen in place?
In general, right? The studies as such, the first study that would happen again for any substation to come is the installation coordination studies. These are how the grid equipments are rated properly. There's a temporary over voltage study. If there's a over voltage, these are analyzed. There are also cases where if there's long transmission line, then there's also additional studies required to make sure that voltage profile or power swing profile that comes through the grid doesn't trip. If there's a transmission level, there's also single pole tripping condition that also impacts the voltage and negative sequence and all that stuff. So we also look into those studies for not only protection settings as such, but also to make sure this meets the grid requirements. We don't want to cause the single pole tripping condition trip some other section of the grid. So that has to be coordinated and studied well. When again, this is on the grid side. When it comes to the solar facility, we look into again a major protection coordination. We look into short circuits. Some of them, PSCAD or EMTP kind of studies there as well. Also, sometimes the customer needs on the transmission level, the PSCAT studies also on the transmission level to be done. We look at that. And there are times when we need to optimize controls, as I was mentioning you. Some of these controls are related to, this tap changes and timelines and capacitor bank operations. So we look into those control studies. Again, so far we are not work on the project with solar farm and BESS together, but there are things coming up where we are discussed now, probably in the next year, we'll see with solar farm and BESS combined together. So now how do we ensure when is the BESS coming in picture while solar farm is there? So that is additional complex scenario that we'll look into. So these are, again, studies as such, I would say not one or two, but again, it requires a whole lot of transient studies to ensure the protection, the equipment, and the controls all are coordinated well and support the grid
Okay.
needs ultimately.
Amazing. And shifting gears to go deeper into industry standards, one of the things we recently posted about that's new to our industry is the updated NERC standards, specifically for inverter-based resources. Can you explain why these new NERC standards are so important for the industry?
Yeah, see, one of the things, again, this is when the NERC, the standards comes in picture, this is coming through a lot of industry experience, right? Generally, a regulatory standard is not developed because it's unlike IEEE standards, again, where we participate and lead some of those things. Those are related to what's good for the industry and what's helpful and better new technology and some things there. But the regulatory standards are generally always developed when there is a really systemic issue. So one of the cases where we see the industry has experienced systemic issues with inverter-based resources, which not only the solar and wind, but also battery predominantly now. So these standards are coming in picture to ensure they provide the response that the grid needs. As I was mentioning you earlier, the inverter-based manufacturers are capable and they can handle, and we talk to them even in IEEE, they say, hey, we can do all these things. On the other side, the grid side, they say, hey, these are not behaving properly and we have problems and so forth. The big question is, what do you need? So the inverter manufacturers say, you tell us what you need, we will provide you. So this is what the standards are coming to. They tell you specifically, hey, we need this voltage right through, the frequency right through, this inertia, this specifically. They're telling these terms, but again, they're telling in the high level where, these are the general response needed. But ultimately, it comes to the utility or the grid operator to identify those specific needs to meet their grid, to say this is what exactly needed. I think there are some California, Texas, New York, they already gone ahead to specifying these requirements. This is what we need. And same thing with the New England ISO, where they said any interconnection that's required, they need to follow provide this response, and they'll study these requirements to make sure the grid remains stable. Then they have to optimize their controls or the response to meet their grid needs. The devils are in the details. There's really quite a bit of stuff there. Again, as I mentioned, we worked on this, including interconnecting with this grid, where the battery, especially with battery capabilities, these are not fully utilized. They can do far more. There's definitely need for more work in this domain to support the
Okay.
grid needs.
Okay, got it. And then speaking to grid developers, are there any requirements that they could do right now to best prepare to meet the challenges that the NERC standards, IEEE 2800, how can developers best prepare to meet those standards, in your opinion?
Yeah, absolutely. For anybody with developer who's doing it, there is already quite a bit of IEEE and NERC standards. There's another one, PRC 29, that tells to protection related stuff, which is similar thing. So if they specify these standards has to abide by, that requires, again, working with the utility or the system operator to make sure it has to be optimally designed. So that takes a lot of risk from their end. If it's not done, of course, at some point, when these standards are asked for or compliance required, then they have to go back and require maybe more expensive design changes to incorporate. So there's already quite a bit of standardization done in the industry. It's a question of just adapting them. And of course, when we say adapting, we just meet just doesn't that suffice. One needs to go a lot more in depth, ensuring, hey, we have this requirement R2, R3. This is how it is met. We require this information we need from utility. Then that coordination has to be done. Just meeting pass or meeting compliance doesn't suffice. So now, many times you see that these reports you get, oh, this meets compliance and done. However, when you try to dig in more, hey, there's really a lot of gray area, unmet needs that are not looked into. So it's required that you get a competent personnel entity who do a thorough job in meeting these requirements and coordinating on your behalf with the utility or whoever it is, or if you take the responsibility, that's fine. Just ensure it's a responsibility of the developer or the owner of the asset to ensure these generation perform reliably and not trip off any time. So there are penalties associated now with NERC regulatory, where if these standards are fall deficient, they can come after you and fine it. Hey, you're not met the standards. The standards has not been looked through even in the past so many years back. So they may go back and fine. So it's important that you do a due diligence to ensuring that these standards requirements are met thoroughly.
Exactly. And what better company to work with that always adheres to standards than L&D? But thank you, Deepak, so much for your insight. Everyone, please tune in to part 2, where we go into additional topics that are very top of mind in the industry right now. But Deepak, it was so lovely talking with you, and I'm excited for part 2 of our conversation. Thank you again so much.
Thank you. Nice talking to you, Nicole.
Bye.
Bye.